I want you to think back to the last time you were driving alone. The windows are rolled up, the world outside is completely shut out, and you just have your favorite music absolutely blasting.
Oh, yeah. Best feeling.
Right. Do you remember that feeling? In that exact moment, was your car really just a vehicle getting you from point A to point B? Or did it transform into, I don't know, something else entirely, like a private concert hall on wheels?
It's an experience almost all of us have had, but very few of us actually stop to consider the sheer physics of how that feeling is engineered.
Totally.
We sit down, we turn a dial, and we just expect this acoustic magic. But the reality is that creating a perfect auditory bubble inside a moving metal box, one that's hurtling down a highway at 60 miles an hour, is honestly one of the most complex challenges in modern engineering.
Which brings us perfectly into today's deep dive. Welcome, by the way. Our mission for this conversation is to explore a truly fascinating column from MMR. It's titled A Journey of World Cars and Sound, and it maps out how car audio has evolved from what used to be just a simple optional extra.
Right, like paying a few extra bucks for a tape deck back in the day.
Exactly. From that into this massive, highly technical engineering feat that the industry now refers to as sound architecture.
And to set the stage for you, the MMR piece makes a foundational point right out of the gate. A car is no longer viewed by its creators as just a machine for moving. It has fundamentally become a space-wearing sound.
A space-wearing sound. I love that phrasing.
It's brilliant. What that means is the entire design of the car, from the structural materials used in the chassis to the aerodynamic quietness of the cabin, all the way down to the physical layout of the interior, it all directly impacts your audio experience. Automakers aren't just, bolting speakers into a finished car anymore.
Right.
They're designing the car itself around the soundstage.
Okay, let's unpack this. Because where the MMR article goes next provides a really fascinating look into how different automotive brands approach the core philosophy of car audio. It turns out the engineering goals for a sound system tell you a lot about the target experience of that brand.
They really do.
Let's start with the engineering philosophy of Japanese automakers. The article describes their approach as a pursuit of delicate harmony. And the ultimate example they provide is the Lexus LS.
A classic.
This vehicle features a Mark Levinson 3D surround sound system. We are talking 17 speakers and 1,200 watts of power. But before we get to the acoustic materials, I have to ask you about that.
Sure.
My home TV soundbar is maybe 100 watts. Why on earth does a car interior need 1,200 watts? Is the goal just to be deafeningly loud?
No, not at all. And it's a common misconception. In high-end audio, massive wattage isn't actually about volume. It's about something called headroom.
Headroom.
Yeah, think of it like horsepower in an engine. You don't buy a 500 horsepower car just so you can drive 200 miles an hour. You buy it so that when you're merging onto the highway at 65, the engine doesn't even have to break a sweat. It just feels effortless.
Oh, that makes total sense.
Audio wattage works the exact same way. When you're pushing complex music, say, a deep bass line layered with sharp cymbals and a vocal track, a low wattage system will start to distort and muddy the sound because it's struggling to supply enough power to the speakers.
Especially when it's competing with highway road noise.
Exactly. So 1,200 watts guarantees that even at high speeds, every single note is delivered with absolute effortless clarity without ever straining the hardware.
Wow. And clarity is clearly the priority here, because the detail that completely stopped me in my tracks regarding the Lexus LS is how they actually achieve that harmony. Lexus doesn't just tune the electronics, they actually select the physical materials for the car's ceiling and the specific fabrics for the seats based on their acoustic correction properties.
Which demonstrates an incredible level of dedication to the craft. I mean, when you put a speaker inside a metal box wrapped in glass, you are creating an acoustic nightmare.
A total echo chamber.
Exactly. Sound waves bounce violently off hard surfaces like glass, creating echoes that muddy the music. Conversely, soft materials swallow those sound waves. So the engineers at Lexus are literally looking at a swatch of leather or a piece of suede and asking, how will this specific material reflect a hi-hat cymbal?
Or will this ceiling fabric absorb too much of the bass line?
Right. It is a holistic approach to acoustic harmony where every physical surface in the cabin is treated as an active participant in the soundscape.
And the source notes that this material-first approach is really widespread among Japanese automakers. Nissan and Infiniti have collaborated extensively with Bose to analyze how sound reflects off the specific cabin materials in vehicles like the Infiniti QX80.
Which allows them to perfectly place their 16 speakers.
Right. Then you have Honda stepping up with their ELS Studio 14 speaker system in the Accord, which is actually monitored and tuned by professional musicians to ensure the most natural, organic sound reproduction possible. And Mazda and Subaru are doing similar work, measuring the specific acoustic characteristics of the cabin space in cars like the CX-5 to completely optimize the environment.
It's a very organic, material-driven approach to acoustics. But if we pivot to the design goals of European automakers, specifically in Germany, the philosophy changes dramatically.
Oh, it really does.
In Germany, car audio is treated less as an organic material harmony and much more as a rigorous extension of precision engineering. What's fascinating here is how German automakers lean heavily into advanced computational technology, specifically digital signal processing, or DSP, to mathematically force the audio into absolute perfection.
The technical specs on these German cars are staggering. The article highlights the Mercedes-Benz S-Class, which partners with Burmester for a 3D surround system packing up to 23 speakers and 1,500 watts of power.
Yeah, that's a massive system.
But hold on, 23 speakers inside one cabin. Doesn't packing that many sound sources into such a small space just turn the audio into a muddy mess of overlapping frequencies?
It absolutely would be a muddy mess if it weren't for that digital signal processing. This is where the computational power comes in. Because you are sitting off-center in a car, say in the driver's seat, your left ear is physically closer to the left door speaker than your right ear is to the right door speaker.
Right, obviously.
Well, without DSP, the sound from the left speaker hits your ear a fraction of a millisecond before the sound from the right. Your brain registers that tiny delay, and the music loses its crispness.
So what does the DSP do to fix that?
A multi-channel DSP supercomputer essentially artificially delays the firing of the speakers closest to you by milliseconds. It bends and times the sound waves so that the audio from all 23 speakers arrives at your eardrums at the exact same microscopic instant.
So they're essentially using a supercomputer to manipulate time and space inside the car.
Exactly. The goal of that massive computational power in the Mercedes is to guarantee that every single person sitting in that car, whether you're driving or lounging in the back right seat, experiences the exact same uniform, perfect sound quality.
That is wild.
They're using mathematics to overcome the physical limitations of the car's layout. And you see this same commitment to engineering precision in the BMW 7 Series. They use a Bang Olufsen 16-speaker, 1,400-watt system.
And they have their own specific technological twist, right?
Yeah, the BMW system automatically adjusts the volume and equalization in real time based on the vehicle's speed. As wind and road noise increase at higher speeds, the computer compensates instantly so you never even have to touch the dial.
And Audi is operating in the same computational space with the A8, utilizing a 19-speaker Bang Olufsen system and multi-channel DSP to essentially recreate a three-dimensional audio stage around your head.
Exactly.
So the German philosophy is to use supercomputers to force acoustic perfection. But what if a driver doesn't necessarily want an analytical, mathematical studio experience? What if you just want to feel the music in your chest?
Then you look to the U.S.
Exactly. That brings us to the American approach. The MMR column points out that the engineering philosophy behind American car audio often prioritizes a visceral feeling of freedom and power. Take the Ford Camaro. It comes with a Bose 12-speaker system pumping out 1,000 watts. But the source specifically notes it's tuned to emphasize heavy bass.
It's an unapologetic, bold sound design. The goal isn't necessarily to recreate a pristine symphony hall. The goal is to deliver a massive, full-body sound experience that fills the whole cabin and matches the aggressive nature of the vehicle.
Which is such a different vibe.
Yeah.
You see a different, highly tech-forward flavor of that American innovation in Tesla.
Oh, absolutely.
The Model S features 22 speakers and 960 watts of power. But the defining characteristic here is that Tesla relies incredibly heavily on over-the-air software updates to manage their DSP. The audio system you buy today can be digitally upgraded, re-equalized, and improved months or years down the line without ever taking the car into a shop.
Yeah, the car evolves. And on the completely opposite end of the spectrum, you have the Jeep Wrangler. It features a 480-watt Alpine system that is specifically engineered to maintain pristine sound quality even when you are battling intense outdoor noise.
Which makes sense. If you're going off-roading with the doors and roof off, you are fighting wind, dirt, and tire roar.
Exactly. The system has to be tuned specifically to cut through an open-air environment, which highlights a great point about intentionality in sound architecture. The Jeep engineers know exactly how their vehicle is going to be used, and they engineer the audio to survive and thrive in that specific acoustic chaos.
Here's where it gets really interesting. Let's look at the engineering philosophy behind Italian and French automakers, because they bring an entirely unique approach to the musical experience.
They really do.
The article highlights the Ferrari 812 Superfast, which uses a JBL 12 speaker system.
Yeah.
But the wattage is listed at only 380 watts. Considering we were just talking about 1,500-watt systems in a Mercedes and 1,000-watt systems in a Ford, why would a brand as premium as Ferrari put such a seemingly weak system in their flagship supercar?
It seems entirely counterintuitive, right? Up until you analyze the core identity of a Ferrari. You're driving a car with a massive, roaring V12 engine. To Ferrari, that engine is an acoustic instrument in its own right.
Oh, I see where this is going.
The engineers realized that putting a massive, booming audio system in the cabin to drown out the engine noise would be a disservice to the car's mechanical soul. I mean, look, you don't buy a V12 to ignore it.
Fair point.
So instead, the JBL audio is deliberately tuned to resonate with the engine sound. The music and the mechanical roar of the vehicle are designed to harmonize. They aren't competing. They are collaborating to create a blended symphony where the car itself is an active part of the track you are listening to.
That is such a brilliant way to frame the relationship between the machine and the media. It integrates the driver into the mechanical experience rather than isolating them from it.
Beautifully said.
The source also notes that Maserati maintains a high-end audio focus as well, utilizing Bowers and Wilkins Nautilus tweeters in their Ghibli model to achieve incredibly high-definition sound reproduction. And just to clarify for anyone who isn't a massive audiophile, a tweeter is the specific type of speaker designed to produce the highest frequencies.
Right, like the crisp crash of a cymbal or the sharp pluck of an acoustic guitar string.
Exactly.
And high frequencies are highly directional, meaning they need to be pointed directly at your ears to sound clear, whereas bass frequencies from a subwoofer tend to just flood a space. By investing heavily in high-end tweeters, Maserati ensures that the delicate, crisp details of the music cut through the noise of the road.
Over in France, Peugeot takes a really clever approach with the 508 model. They partnered with Focal to fit a 12-speaker system that uses spatial engineering to maximize the audio field, even inside a more compact vehicle frame.
Showing you don't need a huge cabin to get huge sound.
Right. It proves automakers don't need the massive, cavernous cabin of a luxury SUV to trick the ear into hearing a wide-open soundstage.
It really is an exercise in acoustic illusion. But if we're talking about creating a pristine stage for audio, we have to examine the approach of the British luxury brands. Automakers in the UK treat car audio with a sense of immense formality. Their design goal is complete acoustic isolation and luxury.
The numbers certainly back that up.
Yeah.
Jaguar, in models like the F-Pace and XJ, uses Meridian's tri-field 3D audio technology to create an incredibly immersive, lifelike soundstage. Aston Martin is utilizing those same Bowers and Wilkins Nautilus tweeters we discussed, but packing 1,170 watts into cars like the Vantage. And Bentley outfits the Bentayga SUV with a monstrous 1960-watt name system with 20 speakers.
Nearly 2,000 watts is incredible.
It's massive. And just like the BMW system, it features automatic sound correction based on speed, but it also continuously measures the ambient environment to keep the audio perfectly pristine inside the cabin. But the article makes it clear that nothing quite compares to what Rolls-Royce is doing.
No, nothing does. The Rolls-Royce approach introduces perhaps the most compelling concept in the entire MMR piece, the silent stage.
Silent stage.
Yeah.
Yeah.
When you look at the Rolls-Royce Phantom, Ghost, or Cullinan, they use their bespoke audio system pushing up to 1,300 watts. But the real engineering marvel isn't just the speakers themselves. Rolls-Royce goes to extreme lengths to isolate the cabin, literally using heavy amounts of aluminum and magnesium in the physical construction of the car specifically to block out the outside world.
Wow.
They use thick, acoustically dampened glass and pack the chassis with sound-deadening materials to create a cabin of absolute quietness.
So rather than trying to overpower the road noise with massive bass or mathematically cancel it out with supercomputers, they just build a rolling fortress that the noise can't penetrate.
Exactly. By eliminating all competing environmental noise, they provide a literal blank canvas for the audio system. It is a studio-quality silent stage where the music can perform without any interference from the wind, the tires, or the traffic outside. It's audio luxury achieved through physical isolation.
While the British are perfecting that physical isolation, the source also points out the new innovators rapidly emerging from Korea and China. Hyundai and Kia are stepping up to democratize this technology, bringing high-end audio to a much broader audience.
A hugely important shift in the market.
Absolutely. The Hyundai Sonata, for example, is using premium lexicon tuning with a 600-watt system that focuses heavily on equalizing sound pressure throughout the cabin. Meanwhile, Chinese brands are pushing into totally new frontiers.
Yeah, companies like BYD, NIO, and Geely are doing incredible things.
The NIO ES6 uses a proprietary 1,000-watt system that is developing entirely new technology to leverage the unique characteristics of electric vehicles. Specifically, they are making groundbreaking adjustments to how low-frequency sounds are handled.
Which serves as a perfect segue into the final major theme of the MMR column. Because the rapid rise of the electric vehicle changes everything about the rules of sound architecture.
So what does this all mean for the future of how we experience sound on the road? I am trying to imagine driving a car with zero engine noise. If the cabin is totally silent, wouldn't every little tire squeak, every pebble hitting the undercarriage, or every sudden wind gust become incredibly obvious and completely ruin the music?
If we connect this to the bigger picture, you've just identified the exact crisis facing modern audio engineers. For over a century, car audio has been engaged in a constant war against the internal combustion engine.
Right.
But as that masking engine noise disappears in the EV era, the cabin doesn't just become peacefully quiet. It exposes all the harsh, unpleasant frequencies that the engine used to cover up. The drone of the tires on the asphalt, the whistle of the wind against the glass, they suddenly become much more prominent.
Because no engine to hide behind.
Exactly. Because of this, car audio is taking on a completely new role. It's no longer just about playing your music. It is about actively managing the entire acoustic environment. The MMR column notes that the car is evolving from a transport machine into what they call a moving listening room, or a completely personal acoustic universe.
And the future tech they list in the source to achieve this personal acoustic universe feels like something pulled straight from science fiction. Automakers are moving way beyond basic equalizers. We're talking about hyper-advanced active noise canceling to artificially wipe out that newly exposed tire hum.
And just to clarify how that works, active noise canceling in a vehicle isn't like wearing padded headphones that just physically block sound. The car literally uses microphones to listen to the low-frequency drone of the road, and then the car's speakers instantly generate an inverted sound wave, an anti-noise wave.
Fascinating.
When the road noise wave and the anti-noise wave collide in the air inside the cabin, they physically cancel each other out before they ever reach your eardrum.
It is mind-blowing physics. The source also discusses next-level DSP optimization. But the concept that really stood out to me is how artificial intelligence is going to personalize sound quality. The article talks about how, in the near future, the physical car seats will actually act as resonance plates.
Oh, yeah, this is incredible.
So you won't just hear the deep vibration of a cello in a classical piece through the speakers. Your seat will physically vibrate to make you feel the resonance of the instrument through your body.
It represents the ultimate sensory immersion. You're no longer just listening to the audio, you are physically experiencing it. And the AI integration the source outlines goes even further. They detail a future where the car's AI will continuously monitor the driver tracking biometrics like your heart rate and analyzing your mood in real time. Based on that continuous data feed, the car will instantly adjust the sound field, the equalization, and the acoustic environment to match or improve how you're feeling. The ultimate goal for manufacturers has fundamentally shifted. They are no longer just competing on who has the most horsepower or even who has the mathematically quietest cabin.
Right, the new experiential value.
Exactly. The new battleground for automakers is answering the question, what kind of sound can we make you hear while driving?
To wrap up this deep dive, it's incredibly clear that car audio is no longer just a bunch of speakers and wires slapped into a dashboard as an afterthought. It has evolved into a true sound architecture. It is this fascinating intersection where delicate human sensitivity and rigorous mechanical engineering cross paths.
Beautifully put.
And as the EV era progresses, the source suggests this intense engineering focus will eventually lead to a sphere of acoustic equality, a standard of incredible, personalized auditory experiences that transcends individual countries and car brands.
This raises an important question for you to consider the next time you get behind the wheel. How does your daily commute soundscape currently impact your mood? Are you actively choosing your audio environment to manage your stress after a long day? Or are you just letting the chaotic noise of the highway dictate your state of mind?
Such a vital question.
The auditory environment we surround ourselves with on the road has a profound impact on our daily well-being.
That is a great point. And it leaves me with one final thought I want you to mull over today,
Yeah.
building right off that idea of AI monitoring our moods.
Yeah.
If the cars of the near future are going to use artificial intelligence to constantly read our heartbeats and track our emotions to alter the acoustic environment,
Mm-hmm.
could our vehicles eventually become our own active behavioral therapists?
Oh, wow.
Think about it. Imagine getting cut off in traffic. Your heart rate spikes. But before you can even physically react with road rage, your car senses the biological shift and instantly adjusts the cabin's audio frequencies to a subconscious, calming soundscape.
That's a powerful image.
Or imagine you're zoning out on a long drive, and the car subtly shifts the spatial audio to increase your cognitive focus before you even realize you were getting tired. We might be moving toward a world where our cars don't just play our favorite songs, but actively use sound to take care of our mental state without us even asking. It is a wild thought to leave you with. Thank you so much for joining us on this deep dive into the architecture of sound. Next time you turn the key or push the button, take a second to listen to the space around you. We'll catch you on the next one.